You guys hear me?
Yes.
It's weird. Oh, there we go. Okay. Okay, I'll just try to talk loud. It's pretty hot. So, how's everyone doing? Sweet. Okay, well, today we're going to start learning about how's everybody on the call?
Good.
Sweet. Okay. So we're gonna start learning about databases today. Um, there's a ton of different types of databases and even of the same type of database, there's like a bunch of options for what to use. Um, has anyone, I think I mentioned a few the other day, but has anyone heard of any particular databases before or know about any of them? Well, like what's one of the names you've heard of, maybe? Mongo is one of them. SQL, SQL or SQL, which stands for Structured Query Language, um, was like one of the first ones. Um, And that's just like a generic term. There's like a bunch of, so that's a type of database, but then there's a bunch of implementations of SQL. So there's like MySQL, Postgres, Oracle, SQL, whatever they bullshit they do. Do what? pSQL is, at least what I know of, is like the like command line interface to talk with SQL. Um, there's SQLite. Um, so they're all sort of roughly pretty similar, except for SQLite. That's quite different than, but like if you're using like MySQL or Postgres, um, they're pretty similar. Um, Mongo was like the first sort of big change, which introduced this term called NoSQL, which is a database that doesn't use SQL. That's all that means. Um, And yeah, it's called NoSQL, NoSQL. And that just means when you are trying to do something with it. So if you're using a SQL database, if you want to create something to store data, or if you want to add any data, or if you want to get any data out of it, you have to write SQL, which is like this text that you write. It's like a command. So it's actually pretty similar. If you're using like the command line, you have to like memorize these ways that you type to it, like CD to this directory. Well, if you're using SQL, you have to sort of memorize a new language for talking with it as well. And it's like select star from table, or create table, or delete star from table, or whatever. Table being like a name of a table that you might create. So it's this very sort of specific structured query language for talking with the database. NoSQL is a database that doesn't use that for talking with it, and it also stores data quite differently. And so Mongo is a NoSQL database. It's the most popular one, probably. And MongoDB is basically you just like store objects, JavaScript objects, basically. So when you're dealing with data in JavaScript, like if you've made an object with Mongo, you can basically just think of like saving that almost like in the same format, exactly the same way. So it's sort of, if you write in JavaScript, you have like a Node backend, Mongo became quite popular because it was so similar to the way that you store data in your application. It was like very easy to just basically hit like click like save basically, and not have to do a bunch of. It's kind of hot in here. I was just gonna try to talk loud and try and get it cooled down a little bit. So it was just like the way that you structured and stored the information was very similar. And so like you could have like an object with like an array of objects in it, and then just shove that in the database and then get it back whenever you needed it. So that became quite popular for a while, but now Postgres is kind of like kicking ass. It's super popular, and a lot of people are using that now. Like that's one of the most popular database options is Postgres, which is just a SQL, an open source SQL database. So nobody owns it. Like Oracle is, owns SQL, whatever they call their database. MySQL is like a Microsoft version of SQL. So it's like closed source, and Postgres is open source. So you can go see the code, you can go work on that project if you wanted to. Nobody owns it. It's a free open license. Okay, so those are the databases. And if you are doing advanced database stuff, then you would need to learn SQL. Like, so let's say you chose to use SQL or Postgres or whatever, then, and you're trying to do a lot of backend stuff. You're a backend programmer. You're going to need to learn SQL and learn how to write SQL. But nowadays our ORMs, which is this sort of meaningless old, or it's not meaningless, it's a specific computer science term of like object relationship mapping. And we still use that term, but it's kind of silly because it's not really what's happening anymore. But that's a term we use. You'll see the term ORM. That's a term we use for like if you're using Node, if you're writing your backend in Node, which we are, and you need to talk to a database, you usually don't talk directly to the database by like writing SQL. You usually use an ORM, and it will like make communicating with the database easier for you. And if you use Python or you use Ruby or whatever, you would also use an ORM typically. So if you're writing your backend in some language, there's usually a suite of options for your ORM as well. So in Node, a few popular ORMs are Prisma, TypeORM, Sequelize, Mongoose, and Mongoose is specific to MongoDB, but these are just a few different software projects that are made for managing and talking with the database through Node. So you almost never will be on a project that doesn't use an ORM to talk to the database. And then that's sort of your main avenue for dealing with the database at that point. And they've gotten so good that like you can sort of get by without having to know SQL at the beginning. Eventually you probably will need to, but like we can do most of the stuff that we need with our database through the ORM directly. So we can use a SQL database and not have to know SQL at this stage of where we're at. So where I work, we use Prisma, which is the ORM I'm about to show you all. And I haven't written a SQL query in a really long time, which is crazy. So yeah, so Prisma, you'll need to be reading about Prisma, but Prisma is a very popular ORM that is for Node. It's for JavaScript. So it's gained popularity quite a bit over the past few years, and you can sort of read about their documentation. You can read their documentation to kind of get familiar with how this thing works. But I will walk you guys through that today, how you set up Prisma and how you work with it. So what's interesting about most ORMs is that they're not database specific in terms of which one you can use. So if you look at data sources. So if you start reading about Prisma, they support Postgres, they support MySQL, they support SQLite, they support MongoDB. So you can write all of your code in Prisma for interacting with the database, and then like with one line change, switch the database you use, and it won't be any different. So it knows how to write SQL queries in any sort of SQL style, whether that be Postgres or MySQL. It also knows how to write Mongo queries. So they sort of abstract away the need to know those languages directly. So we'll be using Prisma. We used to use MongoDB and Mongoose in this class. Even as of like last year, this is the first time we're switching to Prisma. These ORMs have just gotten so good that I think it's just, and everyone's using them. So I think it makes sense to learn Prisma. So this is the first time we're using Prisma, just FYI. Okay, so I'm gonna walk you guys through some code real quick. So in the exercise that we've been doing so far with the coffee shop, in terms of building out the API, we've been using like a fake database that I wrote. And so what I have open here is the coffee shop from where we left off on Wednesday. But so it's the same thing, but I've replaced all the fake DB code that we had with Prisma code. So it's all the same API routes that we had before. It's all the same data, but it's using Prisma now. And then it's using a real database as well. So it's using a SQLite database, It's called SQLite because it's like it's like a local copy of it, and so it's just like a very simple file that has all the data, and it's used typically like in the browser. Um, you wouldn't typically use it in production for your like entire production database. But it's really good for like prototyping and doing stuff locally on your machine. Um, but you don't really have to think about that too much. You just have to think about learning Prisma. So I've replaced all the fake DB stuff with Prisma. So I've got the project running at localhost 3000, and you can see I've got our menu here like we had before, and it's showing all these menu items, but these are actually coming from a real database, coming from Prisma. And I can add stuff to cart like we did before. And then go to /cart. And there's stuff in the cart like we saw before. And I can increment. I think this thing keeps not like having, it's like I don't know why, but my stuff's not refreshing the way I expect it to. But yeah, you can see we can increment the quantity of items in the database. And then we can also remove items from the database like we saw before. So same spot we left off on from Wednesday, but now actually using a real database. So let's walk through the changes I made to see what it took to actually use a real database. Okay, so everything I'm about to walk through, you can learn yourself the same way I learned it by like walking through their documentation. So if you decide you want to use Prisma or any other sort of database ORM, then the first step is basically just reading their documentation. That's how everyone gets familiar with it. So you might read their documentation, or your style might be to look up a few YouTube videos for somebody that like, intro to Prisma or something like that. But ultimately going through the docs is something you'll need to do to learn something that you're using. So that's what I did to set all this stuff up. It was just going through their docs on the ORM, which is all this stuff here. Okay, so that's what I did. They also had like a sample Next.js, like simple Next.js starter repo that I also looked at that I linked to. So that's how I set all this up for this project. Okay, so one of the first things you'll do to get Prisma set up is install it. So you can see we now have two dependencies related to Prisma. One is the Prisma client here, and then the other is just called Prisma. I don't know if I've talked to you guys about the difference between dependencies versus dev dependencies. Dependencies are things you need in production when your application is live and running. Dev dependencies are things you need whenever you're locally working on it. So ESLint is a dev dependency that we have, which is something that just helps us make sure that our code is formatted in a particularly nice way. And you don't need that when it's deployed. You only need that when you're working on it. And then same thing with this Prisma dependency. That dependency we use to like manage our database. It's not actually needed whenever we are live and deployed. So whenever you're reading documentation, you'll see them say like npm i at Prisma client, and then npm i /d Prisma, and the D means like this is just a dev dependency, not a live dependency. Now, if you accidentally just have all of these as prod dependent, like live dependencies, it doesn't matter. It's not going to break anything. It just makes your like artifacts for when you deploy to production just artificially larger than they need to be. Okay, so that's one thing I did is I installed Prisma in the Prisma client. So that's the first step. Then the next thing you do is you add this Prisma folder. So you can see at the top level here, I have this Prisma folder. This just has 3 files in it. It's very basic. So there's 3 files. Normally you wouldn't have this dev.db. Well, it depends. It just depends on what database provider you're using. So since I'm using SQLite, that is the database. It's just a file. So since I'm using SQLite, it's storing all my data right there. So if we click on this, it's kind of like a bunch of gibberish binary stuff, so we can't really read it. But all the data is in there. So when we're looking at our menu here or our cart, that data that's there is coming from that .dev.db file. So you don't really actually manage that file. That's just created by Prisma. And then the other 2 files here, one is a seed file, which is just to like add some seed data to the database. So whenever you're working on a project, you usually need some sort of starter data to be able to actually program in it, which is like, you know, some basic login accounts for our coffee shop. It's like the menu is the main thing, so that whenever we are starting development, we're not just like starting from scratch. We have like some seed data is what that's typically called. So that's what this file is. I'll walk through that in a second. And then the most important file is the schema.prisma. So this is the extension of this file is Prisma. So it's a specific file type to Prisma, and it's our schema. So let me open this. And this file defines what data we want to store. So so far, whenever we've dealt with data in our application, like a shopping cart or the menu, we basically just make an object and we just put whatever properties we want on that object and whatever data we want for those properties. We just sort of do it on the fly. But you have an understanding of what the structure is of that object. So when we made our menu before, what are the properties that we had on menu? What things did we store on the menu? There's an ID, description, price, name, and then those all have types, right? So name is what? String. Price is it's a number. In JavaScript, it like you don't have to think too hard about it. You just say number. But in databases, you typically would distinguish between an integer versus like a floating point number. So whether it has a decimal point or not. But in JavaScript, you just say number and you can store whatever you want in there. But yeah, price would be a decimal or floating point number because it might be like $5.99. It's not like 5 or 6. So when we talk about that, when we say, hey, there's a menu item, it has a name, a description, a price, an ID, that's the schema. So we call that the schema definition. So the properties and then the types of properties, string, Boolean, number. When you deal with a SQL database, you have to be very specific about what data you want to store in it. So you can't just start throwing data into a SQL database you have to design it and create the tables for where you're going to store your data. So if you think about like a Google spreadsheet or an Excel spreadsheet, you typically think of like tabs in that sheet that have that, and they're often called tables, right? So you'll make a bunch of tables in your spreadsheet, and then you'll decide like, okay, I'm gonna have these columns in these tables. And then you would add rows to each of those sheets. So that's, you're deciding, hey, I've got this first worksheet here is orders, and the second worksheet here is people or whatever. And then you decide what the columns are. So whenever we're dealing with the database, we have to go through the act of deciding that and naming the tables. So what we've done so far, we had two tables. We had the menu and we had the cart. And so you can see this up here is like, you don't really have to worry about this. This is saying we're going to use JavaScript for the client. So the thing that's going to talk to the database is going to be the JavaScript client. They're starting to support other languages besides JavaScript. And then the type of database I'm going to use is SQLite. So these are just two configuration items. Pretty simple. The actual meat of it is here. So this is a specific Prisma syntax here. So this isn't like JavaScript. This is very specific to Prisma. So it's just kind of like a new syntax you'll have to learn. But this should not look crazy. This is the definition of two tables. And it's the two tables that we've had so far when building our API. And so I'm saying, hey, I've got in this case, they call a table a model. So I've got a model, and the name of the model is menu. And then inside these brackets here, I'm going to define the different attributes on that table. So these are the ones that you should be familiar with. So we've got, for menu, we've got name, description, and price. And I'm using a specific, so from reading the documentation, I know that these are the different types that I should use. So string, and then float. So float means like floating point number. So there can be a decimal point somewhere. Okay, so I write this, and then I save this file, and then I run a command, and Prisma makes the tables for me. It sets up the database. So it manages syncing and like creating all this stuff in the database for us. Normally, you'd have to write a bunch of SQL. That is like really cumbersome to write, I will say. So normally you'd have to write the SQL command that's like create table menu, and then like all this stuff to make all this other all these other things. So Prisma will take care of doing that for us. I'll show you that command in a minute. And then I did the same thing for cart. So cart is our other table that we had. And the cart was storing just the ID of the menu item and then the quantity. So you can see there's more going on that I'll explain in a second, but you can see I've got menu item ID, which is an integer, which is a reference to a menu item, and then the quantity, which is an int. In this case, it's not a floating point, it's an int. You only have 1 or 2 or 3 or 4 of these things. Okay. So databases have a ton of additional concepts related to relations between tables and like constraints. Constraints meaning like, hey, like this value can't be null, or hey, there can only be one of these things. So there's a few additional concepts in databases that just make it so that you have more control over what kind of data is able to be added to the database. So the first example of that is this notice these like at items after the type. The first example of that is this at unique. So that's a constraint on the table saying, hey, there can't be two menu items with the same name. Like we can't have two lattes. That doesn't make any sense. And so you have this ability to say, hey, don't allow some stupid person to add, sorry, that's terrible. Don't allow somebody to add two lattes to the database. It doesn't make any sense. So throw an error if that happens for whatever, if someone tries to do that. So that's what that at unique identifier allows us to do, is add a constraint for that. A super common pattern in databases is to have two columns that tell you when the item was created and another when it was last updated. And so Prisma actually provides these interesting, in this case, you can use at default in a lot of different cases. So at default is just saying, hey, if somebody tries to add a menu item and they don't provide a value, just use this value as the default value. So that's what at default's saying, which, you could use that on price as well. For example, you can say, hey, our default price is $5 or whatever. But in this case, we have this created at column, which just defaults to now, which is just a built-in thing with Prisma as well, which is just this instant whenever it's being added. But then they have a specific at type here that's updated at, which just means anytime someone updates one of these items, set the time to that moment. So whenever you're looking at a menu item, you know when it was created and you know when it was last updated. It's just like a nice thing to have. So you can see I've done that on both menu and on cart. So I know when something in the cart has been created and updated as well. The other thing you'll see on every table that's just exactly the same, notice it's here as well, is that we have an ID, it's an integer, its type is at ID, and its value is this auto increment. So it basically is handling for us, whenever I add an item to the database, the first one will be 1, and then the second item that I add will be 2, and then 3, and then 4. So that's what that auto increment means. If I delete an item, so let's say I add an item, add a second item, add a third item, delete the third item, and then add a fourth, like that fourth item will be 4. It won't be 3, because it is keeping track of how many items have been added to the database, even if you've deleted it. Because you don't want to like have something that has ID 3 and then delete it and then add a new one. And then now you've got something that has the ID 3 that wasn't that item before. So this is just every record added to a database needs an ID so that you can easily find it. And then this at ID thing here is making sure that it's unique so that, you can't have the same ID twice in the database for a table, in the table. Okay. The last thing to talk about is relationships. So relationships between data and tables is like a huge part of databases. And like Postgres is called a relational database. Like that's in the name. It's like a big feature, a big deal. It's like a big part of what makes databases powerful. So most of the time, your data is going to have some sort of relationship with other data. So think about if you are making Goodreads or something, right? The book website, is everyone familiar with that? So the main concepts in Goodreads are books and authors, right? And so they have a database and they have a table, and that table is probably called books. And every book that Goodreads knows about is in that table. And they also have a table called authors, as like every author that they know about is in that table. What sort of relationship is there between books and authors? One to many, correct. So you guys might not have heard that concept, but that's like a very specific database concept. And to just not use like that jargon, like authors write books. So there's a relationship between authors and the book in the sense that an author wrote it, right? Now, one to many is the correct type of relationship because a book, well, actually, so an author to a book is one author to many books. They may write 5 books. So they like one, okay. But a book to an author is what type of relationship? One to one. So you have this, like a book can only have one, well, it could have 2 authors. And so they're probably pretty annoyed by that. Usually, yeah, that's interesting. I wonder how they handle that. But usually it's one to one, right? So a book usually only has one author. So a book typically in a relational database will have like an author ID that points to the ID in the author database or who wrote it. And then and so that's how you establish, that's typically how you establish that relationship. You say, hey, there's the authors table, they have author IDs, and then whenever you're adding a book, just put the ID of the author in there. And it's not just like, hey, just make sure to put the right ID there. There's actually, in a relational database, you actually say, hey, there's a relationship between this column in this database and this other column in the other table. And so what happens is if I try to add a book and I put an author ID that's like 99999, and there's not an author with that ID, it will throw an error. It won't let me do it. And by also creating that relationship, like specifically in the database, like saying, hey, there's this sort of connection, it will make it so that it can efficiently join the data between those 2 tables. So, because most of the time, let's say you go to the author page on Goodreads. Most of the time, they often like show their books on that same page. So they'll be like, here's the author, here's their bio, here's their picture, and like, here's their books, like right at the bottom, right? So to do that, you would need to query the author table and then join it to the books table because you need both the author information and the book information. And so a relational database makes doing that easy, the joining part. It also makes it fast. So it creates these what are called indexes to make joining that information and looking it up fast. So notice that that's happening here on our menu and our cart. So our cart has a relationship to menu items because we add menu items to the cart. So when I say, hey, there's on cart, there's a menu item ID. And this is just the way Prisma, you do it in Prisma. Like if you're trying to make a relationship to something, we put the ID of the item that we're trying to relate to, and then we add this like at relation thing and say, hey, the menu item ID column in this table references the ID of the menu. Notice this special syntax here, this type. So normally we're putting like int or float or string as the type, but in this case, since we have a model named menu, I can put menu there. So it's saying, hey, I'm related to the menu table, and I reference the ID of that table, and the corresponding column in my table that references that ID is menu item ID. Okay, so that's how we say, hey, a cart can reference a menu item. An item in the cart can reference a menu item. In this case, the way I've set it up, and this is kind of a silly cart because it wouldn't really be that way because our cart would be associated with a user. But the way this one is set up right now is you can only, it's 1-to-1. So you can have a menu item in the cart only one time. That's just the way I set up this relationship. Okay. Any questions?
I got so far, but by establishing this relationship, is it force referential integrity?
Yes,
Like just that alone?
just that alone, yeah. Yeah, that's what this at relation and then this at unique is doing. So yeah, so we write this in Prisma. You basically just have to memorize this syntax. And most of the time, you're just copying another table and then it's almost always the same stuff. It's almost always this exact kind of setup. So you just sort of copy a table and then change the properties, and you might have to, it might be a many-to-one relationship. So or it might be a many-to-many relationship, which you can have as well. Does anybody know an example of like a many-to-many relationship?
Being in your book and not, you could have a minute when you connect
Yeah, if you had, well, what's the example there?
what was like if you and I covered a book,
Yes,
I know you know, I would want to look it up and see that book, you know, your list of authors, but if someone knows me, they would want to look at, you know, so we have a minute.
yep,
Because I might remember, I can't remember Zach Neal was the author, but one of the two.
Yep.
would pop up, you know.
Yep.
In my mind, or not, and then they've done it right, they would have known that there was also another author, that just put.
yep.
Athletes on the team, you know, like.
Yeah, so,
Correctly, you know, we all.
yep, so there might be teams and players. And a player might have played on multiple teams, and a team has many players. Trying to think of another example.
You know, like a partnership that had multiple locations and bars, you know, that part of the setup, right?
Yeah.
Teachers and students, it's a good one.
Yes,
Order table. Order table, taking orders, like, customers,
yeah,
product tables.
yes, I think the teachers and students one's very good though, because it's easy to think about. So a teacher has multiple students, a student has multiple teachers, right? Okay. Any other questions? Okay. All right, so you write this file. And that then says, hey, here's the data I want to store. Here's the relationships between it. Here are the types. You've now defined your schema for your application. And that's it, you're done. Now Prisma will take care of creating all of that in the database for you. What also happens is your schema changes over time. So you're working at a company, you add more and more features and you collect more and more data. So you update your schema, you add new tables, you create new relationships between the tables. Prisma then also takes care of updating your database accordingly as you change it as well, which is a very complicated thing to deal with. Like, and oftentimes you make breaking changes or you like change a data type or you change how you're storing information. And so you have these things called migrations, which are like every developer's nightmare. They're the scariest thing to do in programming. And Prisma helps manage that for you as well.
Full migration.
A migration is like, because like you'll like have like, you know, a huge database full of data in production for, you know, your company. So you've been running for a while, you've had a ton of orders, you have a ton of customers, you know, and you change something in the database and now you need to go like migrate all the old data in the database to be in this new format. And that's always scary to do because you might mess up the code that migrates it. And
So you create a second database for the first and the second.
no, you like live change the prod one. So like you might be changing the type of like, so maybe you had an integer as a data type and you need to change it to a float for some reason. Usually a database can handle that just fine. So you just say, hey, update the type of this column from integer to float. And it can do that usually automatically for you. But maybe you have to change it from float to integer for some reason, which it like is like a lossy operation because going from 499 to 5, you know, is not the same value anymore. And so you then have to write something that's like, okay, hey, just like round everything up and then save that. And so you do that live to the database. That's sometimes why it doesn't happen very often anymore. Most of the time people will like make new columns and then slowly moves up to those new columns. But it used to be when people were down for maintenance, almost always is because they were changing their database schema. They'd have to like turn the API off and then they'd have to like change all the columns and then they'd have to like run a script that like moves all the data and they have to like shut down to do that. You don't see that very often at all anymore because people just handle it differently. But yeah, that used to be why people would shut down. But we're not worried about that right now. Okay.
Now, can you add, like, MongoDB or these to add a constraint, like if you did require a field and you have like 10,000 records and now you want to require it?
That would then potentially break. Yeah. And so you could say, hey, I want to now make this column unique. And it would try and make it unique. And then it'd be like, hey, there's like duplicates in the database and adding that constraint would fail. And it would require you to go update the data before you'd be able to add the constraint.
So like even if you just try to make it where it's a required field versus optional.
Yeah, so if it's a required field, then there can't be any blank entries in the database. And so that would fail too. It would say, it wouldn't allow you to add that constraint.
Microsoft do it and then if you ever access that record again, it will then force you. Does that make sense?
Yeah, that would, I mean, yeah, so that might be like a feature of the database that allows you to add like from now on, it's required. But like Postgres would, if you added in Postgres, this is a required field. It would say, hey, there's null values in the database, you can't do that. Well. You could then add a default. So you say, hey, I want to make this required and the default value is this. And it would then go, okay, I'll make it required. And then any that are blank, I'll set to that default value. Yeah. Okay. So I've written this. This is the schema that we were using. And then I also define the relationship between the cart and the menu. Okay, so Prisma does a few things for us. So if you look at our package JSON, so normally if you start adding new pieces of technology that require you to do certain things for your development flow, you'll add them as scripts to the package JSON so that people know, okay, here are the different commands might need to run for this project. So before we just had dev build start lint. You guys remember that? And we pretty much only used dev. So npm run dev is what we would use to develop. We have 3 new commands that I added for Prisma. One is seed. So npm run db : seed runs the Prisma db seed command, which seeds the database, adds data to the database. There's the db push command, which if I've changed the schema, I run this command and it will update the database to match that schema for me, which I've already ran that command. And then there's the studio command, which is a very nice thing that Prisma provides for looking at the data in the database. Normally, what you would have to do is write a bunch of SQL queries to look at any of the data. So if you wanted to look at what's in the menu table, you'd have to connect to the database and then write select all from menu and hit enter. And then it would show you the data in there. Prisma Studio gives you like a GUI to see all the data in there. So those are some of the new commands that we have. And so I've got the project running, but then I'm also going to run Studio. Okay, so this is the Prisma Studio. And you can see it's got cart and menu. I can click on menu and it just shows me the stuff in the database. So you can see ID. Makes sense, just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The name, the description, the price. You can see our created at and updated at, which are these timestamp values, which is the date. It's a very typical format for a date called the ISO date format, year, month, day. The way Americans write dates is like stupid, so stupid. This is the ISO standard. And then here's the timestamp, including the time zone. Updated at. And then Prisma does this cool thing, which if there are relationships, it adds a link to that item for you. So you can see a few of these menu items are in the cart. Some of them aren't. But for example, latte is in our cart. If we go look at cart, see we just have the ID of the row, and then here's the menu item ID and the quantity, and then also the created at and the updated at. And then here's a link back to the menu item. And so what's cool here is you can actually manually make stuff from here if you want to. And you can see it auto created 11 is the ID for me. Name test, description test, price 5. It automatically did the created at and the updated at, which is just like right now. Notice 15:53, that's the UTC time. And then it's not in the cart, so there's no, but I could add it to the cart. Add a record. It'll make the ID for me. If I try to put an ID that's not in the database, we should get an error about that. The errors on Prisma Studio are horrible, but this is basically the unique constraint being violated, or the relationship constraint being violated. Man, they need to work on this. That's terrible. But that menu item I added was 11, so can change that to 11 and it should work. Yeah. So now if we go back to the menu. Test is in the cart.
Sure, straight auto implement that.
That's that default behavior
Oh.
of this. So the way we set up the ID field is to be the ID and the default is to auto increment. That's what that syntax is. That's just, I mean, you'll just copy that every time you make a table, you just use that same thing.
Check the 99 in there, or did you get saved about anything?
Well, the 99 was not the ID. It was
Oh.
the menu item ID, which there is no menu item ID of 999. That's why I threw that error.
Oh. Perfect.
Yeah. Yeah.
Sure, because you would have to tie it together to say this matches together.
Yeah. So for me, in like the real world, the company I work at, we use Prisma. I use Prisma Studio to look at the data locally and in our staging and prod environment. And if I need to edit something in any of those environments, I do it through the Prisma Studio. And I don't really write SQL queries anymore.
So what?
I don't really write SQL queries anymore. When I worked, the last place I was at was a Mongo shop, so I used Mongo. But then the place I was at before that, we used Postgres, and I would have to like connect to the database and like write SQL queries to look at the data, which like just took a long time. It was like really onerous. So Mongo has something similar to this that they make called Compass. Compass, yeah. It's a pretty nice way to look at data in a Mongo database. Why would I use SQL versus Mongo?
Yeah.
So Mongo is open source as well. Well, they're both popular. Yeah, I wouldn't say that one, I mean, so in the SQL world, Postgres is like kicking butt. But Mongo and SQL are like equally popular. I mean, not equally, but they're both very popular.
Yeah, Mongo is not relational, is that correct?
It's correct, but there's a few asterisks to that. Yeah, it's funny. In Node, a lot of people are moving back to SQL, which is interesting, which is what someone's referring to here. It'll take me a second to find like a graph. So here's kind of what happened. So writing I used to spend a ton of time like writing table definitions and like making tables and like writing SQL code to like manage data. Mongo comes out, and Mongo, you don't have to write anything to put anything in the database. You can just start putting, it has no schema. It's a schemaless store of record. And so you can just shove whatever you want in Mongo. There's no schema. It's just an object, and you can put whatever data you want in there. And so whenever that came out, people were excited by that. Because like your application, your backend code could just like put whatever data it wants in there. It doesn't have to update and run migrations of types and stuff. You can just shove whatever you want in there. And then also, if you had relationships, you could just embed like an array of objects. And so you didn't have to make these relationship constraints and have like separate tables for stuff. You could just like put as big of an object as you wanted in there with like and have the relationship live directly on that object. So people were excited by that. And then like everybody realized after a few years of messing around with this that like types are pretty good, having a schema is pretty good, and having relationships built into the database also pretty good. So like everyone started realizing like the cons of Mongo and started moving back to SQL in certain cases. There's like it depends on what you're doing. So there is no right answer. It may make sense to use Mongo. It may make sense to use Postgres. And so like depending on what I was doing at the company I was at, I would consider that before deciding. But I will say in Postgres, you can also store JSON. So like they added a JSON type in Postgres. And so you can like kind of have the best of both worlds. Like if you need to have something that's unstructured, you basically have like a Mongo database inside Postgres. And then also these ORMs have gotten so good that you don't have to really write SQL anymore. I just write Prisma stuff. And I could switch from Postgres to Mongo or Mongo to Postgres and not change any Prisma code. It just like right here, you just put MongoDB instead of SQLite and it takes care of it. But Mongo doesn't have the same concept of relationships as Postgres, and they started adding it actually. So I don't know. There's really not an answer to that.
What if you had to, like, come from Microsoft Shop, SQL, Oracle, and then you should be in this, and then you're good at integrating across the platform for the analytics or the business intelligence reporting on it. Would you hook up a Power BI or Tableau to Mongo directly, or without the relationships you can show?
It's problematic. You can, but then you have to, yeah.
Someone's gonna have to abstract that. Okay. So then you're gonna have to have some kind of technology to abstract it, warehouses. Okay. Yeah, sounds like a lot of fun work.
Yeah.
So, but then in that case, you might go with a traditional SQL with relationships, and then you can put that fair statement, and then you could hook a Power BI directly to it.
Yeah, most people, it depends on how big you are, but when you start doing a lot of analytics, people will start duplicating the data. Yeah. So that you're not, yeah. Yeah. Yeah.
And then your warehousing and using essentials so you can break.
And most warehouses will be SQL. They'll be, like Snowflake or whatever, and those are all SQL databases and.
Well, like we had, I was interested to go to, we had like, the dudes with big data that would bring in just millions and millions of records per second for measurements across the large, and then they would have to abstract it. Because the relationship gave the cost that, they could.
Yeah. Yeah. Okay, so let's take a 5-minute break real quick.
And it's not going down at all.
Okay. All right, so when we start using Prisma in our application, w- it supports CRUD, right? So we talked about create, read, update, delete. All of those actions are available to you with Prisma. And the syntax is pretty nice. So the seed script, for example, is just a script that uses Prisma to add database to the date or add data to the database. So we are using the C part of CRUD, just create. So if we look at the seed database, you'll see that we import the Prisma client. So the Prisma client is the thing that we use to talk to the database, and usually we have to create it. You won't have to do this in our application code more than once. We just create it and then import it. And so usually we're just importing something called Prisma. And so Prisma is this thing that we'll then have access to that lets us talk to the database. So you'll do Prisma, and then you'll do, so that's the sample data. You'll see here, I'm doing Prisma, and then you do dot, and then you do the name of the table. So menu or cart. And then on that table, you then have a bunch of methods available to you. To create data, there's a command called create. And all of these commands create, it's not called read, it's called like find. There's a lot of different ways to query the database. You can find one thing. You can find something by ID. You can find many things. So whenever we're like selecting or reading data from the database, there's a bunch of different methods you might use for that. But all of these are like if you're deleting or updating, there's a few different things. All of them take an object as a parameter to kind of give it what information it needs to perform that action. In the case of create, we just simply need to give it the data that we want to add. So you can see this script, this seed script, is looping through this menu data array that I made that I'll scroll up to and show you. And just for each item, simply calling prisma.menu.create and passing it the data that I want it to add to the database. And since this is a real database, it like is going to send a query to the database to perform the action that we want. So it's a promise. It's like if it's like deployed in production, your backend server is going to talk over the internet to your database. So there's actually, like, when you think about a real application, you've got your client, your browser, your server, and your database. All three talk to each other over the internet. So, you know, you have your front end talking to your back end, and then your back end talks to your database. So it's a promise. So we have to await it. So this here is simply saying, hey, run adding an item to the menu for me. And it does that. And you can see like each menu item is like menu data here. The thing it's looping through is an array of these objects. And we actually didn't need to provide ID. It would have, I just copied it from my other C script. We didn't need to provide ID, it would do it for us. But name, description, and price are the properties it's adding to the database for us. So what I did is in all of our, like, where do we use Prisma? We use it in all of our API code, all of our API routes that were talking to the fake database before. I went and updated all of those to use Prisma instead of the fake database file that I had written. So if we go and look at our menu, you can see instead of importing that DB thing I was importing, I'm now importing Prisma. And I'm wanting to get the menu items out of the database, so I do prisma.menu, name of the table. And then the method I'm using is find many, which is just something provided by, let's just say, type of query that Prisma has. Meaning I want to find more than one, to find multiple. And if I don't pass it anything, then I just want everything. Just give me every menu item. You can learn about this, and I'll have you guys read some of the documentation for homework. You can learn about that like on this documentation here. So they have a whole page on here's if you need to do any sort of CRUD action, here's the documentation on how to do it. So, we're reading in this case. And in their examples here, they have a user table that they made in their schema that has like an email, for example. And so in their case, they're doing await Prisma dot user because that's the user table. And they only want to find one item. So they're using find unique instead of many. And when they do find unique, they have to pass a parameter that will uniquely identify the user that they're looking for. In this case, email is a unique column in the database. So if you make a user table and you say, hey, there's an email column, you would put a unique property on it. You would say this is unique because you don't want duplicate emails in your database. So this is an example of how you would query for the user that has the email also at prisma.io. So you can see, they're using this find unique method, and then they're passing it this object here that is describing how they want to, like, you're passing additional information to be able to execute the query. In the case of a read, it's usually the filtering that you need to do. In the case of an update or a create, it's the data that you want to create or update. So you can see in this case, they're using this where syntax to find the item. Or you might be looking for something by ID. In that case, we still use this find unique method, but then in the where clause, we just say ID 99.
So it's the same, the where columns,
Yeah.
select star from
Where, yeah. So yeah, if you want to get all records, how I know how to get all records is I read this page. I looked at that. Oh, if I want to get all records, I just simply run find many. And so that's the syntax I'm following here. Prisma dot not user, because I'm not hitting the user table, but menu, because I want to hit the menu table, but then same syntax, find many. So get all. So this menu items is going to be every single menu item in the database. So, when we were looking at Prisma Studio, if I do find many, I'll get every single one of these rows. And Prisma, so this data here is like in SQLite, it's like, it's like a table, right? So it's like columns and rows. But whenever we get the results back, it will be, in this case, an array of objects. So it's going to turn it into what we're used to in terms of dealing with data. So if you ask for one row, it would just be an object. But since we asked for many, it's going to be an array of objects. So I simply just return, response.status 200 JSON and just return those menu items from the database. So even though we switched to using an actual database, and that database is a SQL database, like we're using Prisma, it handles like turning everything into the format that we're used to for us. So there's really not much to do there. It's just, we just simply ask for the data and then just send it in the API. So now whenever we load our menu page, we send that query to hit, with a GET request /API/menu. That's responding with this menu with these items. But notice I have created at, updated at, the ID, the name, the price, the description. So that's that record from the database. And that is all happening from, you know, on our menu. Like on load of our main root page, we call this load data method. We hit /API/menu and get the data back. That is hitting /API/menu, which is this API endpoint, which is, it's just a GET request. And so it's hitting prisma.menu to find menu and then just returning everything from the database.
So queries gets all the menu options and it builds out the menu. Almost the database.
Yeah, so all those menu items are from that seed script that added all of them to the database. But yeah, it's just getting all of them and returning them to me. You can see all 10 item or 11 items that are in the database are getting sent back in the API and then showing up on this page here. So remember, I had manually added one to the database that was called test, like that's showing up here. If I go manually add another one. I just added another one. If I go back to the page, I'll need to refresh it so that it sends the query again. But now, you know, another test is there. I don't think it saved the price, right? It looks like. So it was 0, the price. I go ahead and I changed with an update. So this is an update query, just to update the price. Now it's 4. If I go back here and refresh now, that has price 4. So yeah, we have real database, real server, real front end. You know, if you add data to the database, it will show up, you know, the server will see that and it'll show up on the front end. Yeah. Yeah. So if we add to cart, right? So we add a latte to the cart. We're sending a post request, right, from the front end to the server. We're saying, hey, hit the cart post route. And then the data that we provide, right? So if we look at our network and hit add latte to cart, or actually let's add this new one. So another test, it's not in the cart, right? Because we just added it to the database. So we click add to cart. We make a post request to /API/cart to add something to the cart. The payload for that is the ID. We've seen a mix of using the ID in the URL versus like in the payload. You can kind of decide. In this case, we put the ID. Now don't get confused because we've got every table has an ID, right? In this case, the ID here is the menu item ID. So we're adding another test, which was the 12th item in the menu table. We want to add that to the cart. So the ID here is the menu item ID. And then with quantity is 1. That's just what we sent in the payload. So if we want to see what that route does, we can go look at that route on the back end. So we go to API, cart, and it's the index. Because it's just /API/cart. So that's the index handler for cart. And the request method is a post. And so we look for the request.body.id. I'm calling that menu ID because that's the menu item ID. It's not, when we say ID, that has to be sort of contextual to a particular table, right? So I probably could name that in the front end. Like it would have been better to probably call that menu item ID. But then we're following the same syntax that I did before. I'm using Prisma in this case. So I've updated all this code to use Prisma, but we do await Prisma dot cart, right? So not menu, but dot cart. We want to talk to the cart table. And then I'm using this syntax called find first. I could also, I actually could change this to find unique because the menu item ID is unique. So I could really change this to be that, but this still works. And so I'm saying find the first item in the table where the menu item ID is the menu ID from the body. Like, so in this request that we just did, it was 12. So it would look to see if that's in the cart. It's not in the cart yet, right? So we haven't added it yet. If it was in the cart, it would run this update method that Prisma provides. So prisma.cart.update, but it's not in there. So it's running prisma.cart.create. With the create request, you just need to provide it the data that you want to create. And so I'm saying, hey, here's the data. The menu item ID I want to add is 12 in this case, and the quantity is 1. So this is just calling the built-in, Prisma create. It awaits it, and then it responds, hey, we successfully added that to the cart. So we look at this, its response was item added to cart. And then if we go to cart, we should expect to see ID 12 with quantity 1 in the cart.
Is that a search statement?
Yeah. Yeah. So if we want to, we can like turn on like the Prisma debug mode, and it will like log every query that it's running. And in that case, you would see, it does everything in like a transaction, which we don't need to worry about that. But eventually, yeah, but it will, insert into cart values.
Yeah.
It turns that into an actual
So it
SQL.
doesn't do behind the scenes.
Do what?
It does it behind the scenes.
Yeah.
Okay.
So okay, yeah. So we can look in Prisma Studio if we want to. Hey, did that get added to the cart? It did. So menu item ID 12, quantity 1. And if we go back and go to /cart, we can see. Oh, yeah. Wow, that threw me. Okay. So what we're showing on this page is the ID of the cart, not the menu item, which, I mean, this is useless, right? No one wants to see a page with 2 numbers on it. So we can change that. But this is showing the cart ID and then the quantity, this is correct. So if we look at this page, 4, 6, 7, 8, 9 are the cart IDs that we can see, 4, 6, 7, 8, 9, and then the quantity 11, 1, 2, 6, 1.
Or to make that more useful, give like a name or a title, you can show that.
So to make this more useful, we want to get the cart, and we want to join it to the menu, most likely. Like, we don't want to show the menu ID, we want to show latte or whatever else, right? So this is our first example here where it's like, oh, okay, I need to have these relationships, but I also need to be able to like join the data from 2 tables together to show something useful. And so Prisma has an easy syntax to say, hey, query the cart, but join all the menu items to it. And I'll show you that here in a second.
But you would add a name to that table because then you can start utilizing it, right?
Yeah, and so if you guys read, I know I sent it yesterday, but if you read that README that I sent about database intro, there's the concept of normalizing and then denormalizing. So like having, so we have the menu table that has the name of the menu item, the description, and the price. And then we have the cart. The cart has a menu item in it, right? But the most efficient way to store the information so that you don't duplicate a bunch of information is to only have the name and the description and the price in one location in your whole database, and then just reference the ID in the cart. Like that's the most efficient way. And in Mongo, a lot of times what people would do is they'd have the menu, and then when they make the cart, they would just put all the data for the menu in the cart. So that when you query the cart, it has the name of the menu item in it. And so you're sort of like duplicating information in that case, though. It's nice because you don't have to do a join, like all the information you need to show the cart's there. But it's not as efficient in terms of like a data storage standpoint.
But by doing that, you would still do a, you could still link it to.
You still link them potentially.
You just set it up.
In the Mongo world, you would put, hey, here's the original ID of the menu item, but duplicate the data, and then or well, yeah, but it doesn't actually have like that relationship would be there, but there wouldn't be like the same sort of constraints that would ensure that yeah, you could, and it wouldn't break anything. Yeah. Yeah. Okay. But so we are using a relational database. We would store our information the way that we've stored it so far. And then when we need to see data from multiple tables, we can join them together. So there's a syntax in SQL to whenever you're running a query, you can join as many tables as you want. You could have one table that references like 15 other tables, and then you can join everything together. Now, it might take a minute, depending on how complicated the relationship is, but that's the thing we can do. So let me walk through some more of this code real quick, and then we'll do that. Yeah, you can see on our backend here, we've got examples of both reading, so this find first, or like the find many that we saw, creating, which is just create, and then also updating. And when you update data, you need to provide not only the data that you want to update, but you also have to provide what data you want to update, like which particular record in the database you want to update. So that's why you can see this in this example of an update. When we were finding, we just had the where, and when we were creating, we just had the data. But when we update, we need the where and the data, because we're saying, hey, go update the item in the database with this ID. So hey, if we're wanting to increment the quantity for this record, it's going to go find the cart item that has the menu ID that we're specifying and updating the quantity for that one. So you can see I'm saying, hey, update the cart item with menu item ID of whatever it was, and then up the quantity. Here's a delete. So a delete method is, all of these method names are pretty simple. So if we want to delete something from the cart, we run the delete method, and we also have to provide the information on what we want to delete. So there's a where with the menu item ID. So if we want to remove this one, we are using that delete method.
So I want to get an update what you like.
Yeah, that's a good point. So normally you would expect if we're doing an update that that's technically a put, right? In this case, I'm handling in this one route, I'm handling creating or updating. Because we don't know for sure if it exists or not. And so like that's fine. There's no HTTP verb like get, post, put, delete. That is the actual term here is called upsert. Which means update it if it exists, or insert or create it if it doesn't. So there's actually a Prisma command called upsert that we can use. In this case, I sort of built my own. I looked for it, and then if it exists, I update it, and if it doesn't, I create it. But in this case, it's okay. I mean, it's okay to do that in a post.
You could have flattened that code out like insert.
Yeah. But that's a fancy, I mean, yeah, I wasn't gonna show that, but that is something that exists.
Do you see that? In the real world?
I use upsert like all the time.
Yeah, versus
Yeah. I almost always use upsert over like create. Yeah. Okay, I think. Yeah, so we've seen an instance of find many. We've seen create, update, delete. Okay. So there's two more things I want to show. So we'll show the joining, which is pretty cool. And then I want to show, so, when we're creating or updating or deleting data, it's usually pretty simple. It's like, here's the data, and like, here's the ID of the thing I want to create or or you don't have an ID if you're creating something, but if you're updating or deleting, you do. When you're reading data, you're usually not like, so we've only seen find like by something unique, like the ID, or just find everything. But usually you're doing somewhere in between that. So whenever you're getting data, usually there's a bunch of additional sort of filtering or parameters that you would typically provide. Because when you're looking at any sort of data, there's always some sort of criteria that you're including. So if you're looking at news, for example, it's like today's news. So there would be like a where clause or a filter that's like, hey, get me the news from the past day or the past 7 days or whatever. And then usually you don't normally see this, but usually it's also paginating it. So if you've ever dealt with if you've ever looked at like Google results, right? That's like the first page of results. And so there's another, like every database has a mechanism for paginating. So you normally what happens is you say, okay, like think about a Google search. So you open Google and then you type something. And so the search query is whatever you typed. So if you type JavaScript, then you'd be sending, a GET request to Google with the query JavaScript. And then it would also include like who you are, which usually changes the results as well. But if you ignore that, you'd be saying search for JavaScript and then give me the first page. And the way that we typically do page is we say, give me like order these results by something. So either that's like by date, or in this case, it's relevance of the match. And then give me the first 10 or the first 20. And then if you go to the next page, it would be the same query, but then it would say offset by 10 and limit 10. So to do pagination, there's these terms called offset and limit, meaning limit the results. Because JavaScript matches like, 5 billion results or whatever, like a massive number of hits. But you want to get the first 10, so that's limit the return to 10. And then if you want the second page, you're limiting it to 10 still, but you want to jump the offset. You want to jump 10 results. So whenever you're doing a find many, you almost never are just sending a blank query. Like, because when we got all the menu items, we did find many with no criteria, just find everything. But usually, in the real world, you'll have some sort of filtering criteria. And so that was one of your to-do items, was to provide a search query. So, whenever we're going to the menu, we might type in coffee or cappuccino or latte, or we might filter by price. We might say price less than $5 or something like that. So those are all things you could pass to the API. You could decide, okay, if they're going to filter on price, then I'll put that into some sort of query that will be passed back to it. And then you need some way to pass that to the DB. And that's pretty easy. So within find many, we just pass it a where. So we're providing an object always to Prisma. And then depending on what keys we provide, that'll do different things for the query. So we want to filter on where. And then one of the columns in the database for menu is price. And so we can say price. And then they have, and all this syntax is in the documentation, I'll have you all read, but they have a key called less than that looks like that. So when you say, give us everything that's less than $4. And that's the syntax for it there. So if we go back to the menu, 542-655-555-35. So a bunch of results here are more than $4. And I can update this query to be everything that's less than $4. And refresh this page, and now you can see we're only getting 2 hits. Or I can do less than or equal to 4. We get the 4 as well. So every database is going to support an extensive amount of like filtering operations as well. So when you're doing a find many query, you're usually providing a lot of filtering as well. And so you can filter, and so depending on the type, so in the case of numbers, less than makes sense. But in the case of name, for example, we can do like string matching and stuff like that. So we can do like, where the name case insensitive contains coffee or something. Is something you can do easily. So all of that information you'll be able to find when you read through their CRUD examples. They explain all of the syntax and options. You can see this filtering and sorting. So they explain all so here's an example of prisma.users.findMany where the email ends with Prisma.io, So there's all types of filtering options. And you can sort as well. Obviously, it makes sense. You might want to sort by the created at date. So, whenever you query the menu, it could be sorted by the most recent first. So that's why having a created and updated at field is usually really helpful for sorting. Okay, so last piece is doing the join. And you can see they've got documentation for that here, which is this relation query. To include a relation, you use this include key. So if we go to our cart. And so far we do prisma.cart.findMany. Which is just responding with all the stuff in the cart. But if we want to include the menu, you just pass an object here, you use the include key. And then you just say, in this case, we have to kind of reference our schema. So on cart, we defined that relationship here. We said, hey, there's the menu item ID that's in there. That's that int. But then the relationship is this thing here. And by default, relations like this aren't added. So when we did find many on cart, we were only getting ID, menu item ID, quantity, created at and updated at. By default, it doesn't do the join. But if we want to, because that's an expensive thing to do, potentially. So if we want the join, we just have to specify to include menu item is the name of that column. And so we just go to include and we do menu item and you just put true like this. So that simple addition of that object and saying include the menu item will do the join for us. And so if we go back to our cart, nothing is different yet because we're not referencing that data. But if we look at the return value, you can see we've got created at ID, menu item ID, quantity updated at, and then we have this nested object called menu item, which then has all the properties from the item in that table. So the created at, description, ID, name, price, etc. So now what we can do is in each of these cards, we can reference those menu item properties to show something better than 6, 7, 8, 9. So let's do that. We can go to cart. Cart, here's our cart. Cart items. So instead of item.id, we might do item.menu item dot name. Yeah, so I updated, so we had an API endpoint. You know, when we load the cart page, we hit the API endpoint for, you know, /API/cart. So get the cart. And so for get, for that method, we do prisma.cart.findMany, which is query for everything in the cart table, every item in the cart table. If we don't pass a where clause, that filters it. And so that's what it was doing before. It was getting everything in the cart, but there's a relation in the cart to the menu that's defined in the schema. You know, whenever we add an item to the cart, we're specifying an ID of a menu item, which is a reference to items in this table. And so if we look at remember the Prisma Studio has, you know, we can look at the data in the database, menu and cart. And if we look at the cart table, you know, it has ID for the cart ID, and then it has the menu item ID, and then the quantity. So this table is like just like storing references to things almost, you know. It's like. Here's like item ID 1 from the menu is in the cart. And there's one of them in the cart. That's all this, like, all the information in this table is just. Menu item ID 1 is in the cart. Menu ID 6 is in the cart, and 11 and 12 are in the cart. That's what it's storing. And we query this table. So it gives us back these 4 rows when we do find many. So, Prisma.cart.find many gets back these 4 rows. But since we specified that menu item ID is a relation to the menu table, we can tell it to include the data from that table. And so it basically is like this row also contains all the, so menu item ID 1, it's like we also have all of this information. And so when we say to join it and include it, it's basically like joining all of these columns into this table. It's like we made 2 tables basically. Or sorry, it's like we took 2 tables and like smashed them together into one and then got all the results back. So all that to say, when we look at our menu and we say, add espresso to the cart, we do that. And so now when we go to cart, it's some odd caching thing. I don't know what that is, but you can see espresso's in the cart. The cart is only storing the ID reference to menu, but we can then join it so that we get all the data for the menu item to show here. So we have not just that espresso is in the cart, but that 1 espresso is in the cart. Or we could say, hey, let's have 2, 3, 4, 5, 6 espressos. The cart's job, that table, is simply to store what is in the cart and how many. That's all it needs to store. And then, but whenever we're trying to show a page, whenever we're trying to show someone's cart, we want what's in the cart and how many, but we also want the information on those items in the cart. So we need to kind of join those together to show it.
Like, site what information. Right.
Yes, so we probably don't need to show all that, right? But they might at some point be looking at this and being like, shit, what was that thing I added to the cart? So usually this would be a link, right? That they could click and it would take them to that menu item. And so that to do that is quite easy. We make menu item detail pages. So like we don't have that right now, but here's the whole menu, right? But you might click on flat white and it would take you to a detail page for flat white. It has pictures and reviews and all kinds of extra information. So we'd have like a /menu/ID page that would query for whatever ID you pass it, the ID for flat white, and show you all that information. Well, then you can get to that page by clicking on, you would just have an Ahref here to that page. So you could get to that page from here, or you could get to it from the card, by clicking on it. It's just a Ahref to the same page. Yeah. Okay, that's like everything. You guys learned everything. So, I mean, yeah, that's all the pieces. So you guys have seen front end, you've seen server, now you've seen databases. So yeah, it's all the concepts, it's all the pieces. And like the rest of this course, it's just getting more familiar with using Prisma, adding your own tables to a Prisma schema. But that's, you know, that's all the foundational stuff. You did it.
That's fine.
Using what?
That's fine.
Uh-huh.
But whenever it's all aspects of it. Create the next app. It's all.
So, what I would recommend is you just like copy the folder that I have here to start, and then just do npm install. So whenever you like copy a folder, and you know, you have this package JSON. If you just type npm I with nothing else, it'll just install everything in the dependencies and dev dependencies for you. So I'll just have you copy what I just showed you all as the starting point, and then you just run npm I, and then from there you can run. Well, you'll have to run, because you'll have your own copy of the database, so you'll need to run the seed command and the push command to sync the database. But I'll give you all those instructions. But if you were starting from scratch, I think, which might have been your question, you know, you would do a create next app thing. So, you know, Next.js, they don't care what ORM you use, you know, they want to allow you to use any ORM. So they don't have that built in, right? So you know, you would do create next app, and then, you know, you decide you want to use Prisma. So then you would follow Prisma's documentation on adding it, so that they'll have these like quick starts, for example, you know, like add Prisma to an existing project. And so this is walking you through how to set it up. Or what I did was, you know, they have their examples here. So they have like a GitHub repo with a bunch of example projects that have Prisma set up. And for us, we're doing Next.js with REST. REST is like a RESTful API. And so this was the example I looked at. And so I just looked at, okay, what is needed in the package JSON that I don't currently have, and I added it. And then what is in this Prisma folder that I need, and I added that. But then I updated it. So here was the one they provided. So I copied all this, but we don't have a user or a post model. So I renamed these menu and cart and updated the schema appropriately. I changed the seed script, so they have user data that they're adding. I made it menus. And then the only other thing I didn't show you guys is this file, which is where we're creating that Prisma import, but you don't need, like, I copied this exactly. So that's how I added it to so we had our basic next thing. I went through this and just added the pieces that were missing.
On that CJS, you very much like a flat file like a CSV and populate like a lot of data.
You could, yeah. Yeah. I mean, you'd have to install a CSV reader in Node. Like, you would just have to write that code yourself, but you could
You have to write the code, go to CSV file.
pull the data out of it. But there's a node like CSV reader library. And then you would just loop through that. Well,
Basically, map it.
yep. And then just Prisma create method calls for each row.
I'm sure you can find online, you can say I want it, you can just.
Yeah, for sure.
And then you just-
Yeah, their docs,
Hey,
yeah. Their docs might even have something. But yeah, so I mean, everything to get started with Prisma. They have documented, like I don't know how to do it. I like go read the docs and do it. Yeah, so that's kind of the name of the game at this point, because like once you have a foundation of all the concepts, then it's like reading documentation and Medium articles or Stack Overflow posts to figure out, how to add what you want to add or do what you want to do. Okay, so the homework will be, I'll send instructions on you guys getting all this set up locally. And then I'll have you guys update a few of the queries and then add your own table, add a new model. So we only have the cart and the menu, and so we can add the what did I call it? Orders, yeah, orders table. Yeah. Okay, any other questions? Do what?
That's not till August. Then August, yeah, August, thanks. Oh, yeah, cool. I just looked at it, second.
All right, see you all.
He's,
Yeah, have a good weekend.